The Spiritual Dessert Trews, episode 105 for Russell Brand and other people. Welcome to the Compatibility Gene. That's where we're reading from. And we are on the topic of sex and smelly t-shirts. That's the title. I didn't make it up. It's pretty funny. Last we got on to the fellow with the beard. He was collecting his beard shavings and he realized that the beard was growing much longer, much faster when he encountered people. So that means when people look and they think, wow, what long hair you have, that means it grows longer based on what people are thinking about you. That's funny. So you have to stay away from people. No, maybe. I could think something awful and then help you to make it come true. Thanks. Benefits of being a loner. And the fellow with the beard was a loner. But when he went to the mainland, his beard grew more the more he went on the mainland. Thomas saw this to also signify a newfound interpersonal communication. Another observation reported at the time was the spontaneous synchronization of menstrual cycles for women living together. 40 years on, menstrual synchronization still remains controversial. Although 80% of women believe it happens, there still is an agreement among the scientists whether or not it really occurs, never mind understanding how it works. Thinking about these phenomena, Thomas, as well as others, that's the scientist, realized that if people or animals could sense each other in some way, perhaps by smell, there had to be a fixed genetic component involved because one's identity is constant. Thomas suggested that compatibility genes could provide such an identifying mark because they varied so much between individuals, and crucially this seemed to fit with the Boise's, some other scientists, observations. So as a team they set out to test the hypothesis directly by caging together different mice. Poor mice, they're always being tested. And simply observing who mated with whom. Clearly not an experiment that's ethically possible to do with humans. It could be. Deserted island people. The team's careful experiment confirmed their anecdotal observation that when a mouse is presented with the choice of two potential mates, its preference is influenced by compatibility genes. But how? Did mice detect each other's compatibility genes? Smell was one possibility. So Ted Boise got in touch with a renowned expert on olfaction, Gary Beauchamp, in Philadelphia, largest research institute in the world, the Monell Chemical Senses Center. I think I should go work there. My nose works too well. I will suffer. The largest research institute in the world. They focus on understanding taste and smell. They got to know each other over the coming decades, and when I spoke to Beauchamp in 2011, it's pretty recent, he was always having original ideas. He recalled beyond their experiments on smell. For example, Boise also suggested using umbilical cord blood as a source of stem cells for transplantation, a brilliant idea, which became widespread medical practice from the early 1990s. To study the mouse sense of smell, Boise, Beauchamp, and Thomas recruited a researcher from Japan, Kunio Yamazaki, to carry out, got cut off, phone call. It's like 2 o'clock in the morning. Who's bothering me? To train mice to use the maze, the strong smells of the juniper and cinnamon were blown down the branches. All right, so they were trying to get to see like where the mice would go, depending on what they were attracted to. Next, again, the offering appropriate awards. Mice would be successfully trained to smell other mice placed on the to carry out a series of experiments using a Y-shaped tunnel, formerly called a maze, equipped with a fan to blow different smells down each branch of the Y. Mice placed on the bottom of the maze would run into one of the 2 branches of the Y, depending on the smell they preferred. Trained mice to use the maze, the strong smells of juniper and cinnamon were blown down the branches, and mice were rewarded with a drink when they went down the juniper-scented track. Next, again, by offering appropriate awards, mice would be successfully trained to smell other mice placed on the pronged end of the Y who had either the same or different compatibility genes. This showed that mice were able to detect the type of compatibility genes another mouse had to make an appropriate choice and win a prize. The team then found that they could repeat these kinds of experiments by replacing the actual mice being smelled at the prongs of the Y and samples of their urine, again using fans to blow the scent down the tunnel. While this doesn't rule out other ways that mice sense compatibility genes, this show that smelling urine is one way that they can. Rats also shown to be able to identify each other smelling urine. Thankfully, it's a lost skill in us. Two big questions arose from this discovery. First, what do animals use their ability to sense each other's compatibility genes for? And second, is anything analogous true for humans? As for the first issue, we still don't know the answer, but there are several possibilities. One idea is that these genes could be used as a mark of kinship, employed by mice to avoid inbreeding or incest. Another possibility is that mice use these genes to find relatives for communal nesting. Mothers may recognize their children this way, for example. And a third possibility is that mating preferences might specifically help keep immune system genes diverse, since leaving different strains of mice to mate will lead to offspring with more diverse compatibility genes than would be expected by chance. But what of the second question? How does this relate to humans? Can we also unconsciously assess the compatibility genes and potential partners? Are we secretly parading our genetic makeup to everyone around us by our smell? Regardless of whether or not we choose to? Show off our status by flaunting wealth or good looks like peacocks? John Van Rood, one of the pioneers of the HLA research, who we met in Chapter 3. Well, we didn't meet him yet. Among others, tried to test this in the 1980s, but his results were inconclusive because, as we said, smell is inherently difficult to measure. Then, in 1994, Wedekind took up the challenge with a now infamous and provocative experiment. He first established which types of compatibility genes a cohort of students had. 49 females and 44 males. The women, who happened to be mainly taking courses in biology or psychology, were then asked to take care of their sense of smell by using a nasal spray for 14 days and to sensitize their perception of smell by reading a fantasy novel on perfume, the story of a murderer. The men, mainly studying chemistry, physics, or geography, were asked to wear a plain cotton t-shirt for 2 nights and refrain from anything that might affect their odor: sex, smoking, drinking alcohol, using deodorants, or even entering a smelly room. After these 2 nights, the men's worn t-shirts were placed in cardboard boxes with triangular holes. Then, alone in a room, each woman smelt 6 different t-shirts and ranked them on a scale of 0 to 10, 5 meaning neutral and 0 meaning unpleasant, against 3 criteria: intensity, pleasantness, and sexiness. And just before the results had been analyzed, there was already a problem. Journalists had picked up the scent of a good story, and some students had received letters asking for their participation in the study, thought that the research sounded dangerous and unethical. The second largest newspaper in Switzerland at the time published an article quoting students protesting the project. One was reported to have said, "Media, they don't want us to know. We're so simple. Boils down to some genes." That's why they sell us perfume. So this way we can't know each other. It's all about separation, isn't it? That's it. No more deodorant. It's gonna be me. You know what's really funny is my brother, he had to find his t-shirt. We went to Catholic school, so you couldn't find your uniform after you took it off in gym class. So he had to find his t-shirt. And I was in a pile of t-shirts, and they were all the same. He was in trouble. So he picked them up. There was a bunch of sweaty t-shirts. So he smelled them. And each one that he smelled stunk because they were sweating. He smelled it, and he put it down. That's not mine. He came to one, and it smelled like nothing. That was how he knew it was his t-shirt. I never forgot that story. That was my real-life practical application of this. So, going back to our story, politicians panicked. 2 phoned Wedekind. One said that he had heard about his Nazi research. He said that the work must stop immediately and that they would do everything in their power to have him removed from the university. Took notice of the furor, but concluded that there was nothing wrong with the experiment. So, back in the lab, Wedekind and his co-workers analyzed their data to compare the preferences women had for t-shirts worn by men with similar or dissimilar compatibility genes. Specifically, HLA, A, B, and one of the class 2 HLA genes, chosen for being important in influencing transplantation success. Hence, tests for these genes were readily available. The outcome was that the women ranked t-shirts to be more pleasant and sexier when worn by men with different compatibility genes from themselves. Women's rating for the intensity of smell didn't correlate with compatibility genes, confirming that it was pleasantness or sexiness that was important here. The experiments seem to show that we unconsciously favor sexual partners who have different compatibility genes from ourselves. And there was another dramatic result. Women taking a contraceptive pill didn't show the same preferences. In fact, their tastes were reversed, so that women taking the pill preferred men with similar compatibility genes to themselves. One way of interpreting that is that during pregnancy, to some extent mimicked by the effects of the contraceptive pill, selecting a sexual partner becomes unimportant. So, preferences are altered, and a pleasant smell might instead be associated with family members who have similar compatibility genes. Wittekin concluded that if mate preference was linked to our survival from disease, then the negative consequences of disturbing this mechanism by the use of perfumes and deodorants or by the use of the contraceptive pill during mate choice need to be known by users. He sent his paper describing his research to the top scientific journals, but ran into trouble again. One reviewer for Nature said that his method was simply not rigorous. Papers in Nature usually report scientific methods of dispassionate protocols, with details about the dose of the drug and the number of cells tested, not a method which stated that the subjects were first given a book to read. Surely the results can't rely upon women reading a particular book, the Nature reviewer queried. Would results change if they were given a different book to read? The reviewers also questioned the effect of the nasal spray. We've got quite a few pages of this. Is it time for bed? Maybe it is. Ah-ha! Nighty-night. Pleasant dreams. Mwah, mwah, mwah. Kiss, kiss.